we have most people on board, so let me slowly start. My name is Lorenz Meier. I founded the PX4 project 10 years ago, but just founded it. It's really been developed by so many people, in particular Daniel, and so I consider myself maybe still a spokesperson, but it's really you that make up this project and that move it forward, and that's really cool. I'm actually on travel right now. You don't see the usual setup we have in Zurich. I'm in Silicon Valley right now, Palo Alto, which is again a new thing after this really weird time over the last couple of years. And I'm glad to be on the road again. So I'm looking forward to meet more of you in person. But today it's still going to be virtual. So welcome to the PX4 Dev Summit. It's going to be 2 very interesting days. That's quick background on myself. Not going to spend too much time on it. If you're interested, these are all the projects I founded that have been carried on by so many people that took the lead. And with that, a big thanks to all of our contributors. These are not the profile pictures of each and every one, but we're trying to have as much representation as possible. So thank you all for your pull requests. Please keep them coming. Thank you for your issue reports. Thank you for the ideas and contributions. And that's really what makes us here as a community big. A little bit of history for those who have not seen that. This whole ecosystem really started 2008 back at ETH Zurich with a student team. We wanted to do obstacle avoidance and autonomous flight with computer vision. Back then, the first problem, however, was that 2008, you couldn't buy an affordable autopilot. So we actually went ahead with the initial 14 students to build our own. Somehow managed that within 9 months. I'm still amazed by that. And had a complete system flying. Back then it was a coaxial helicopter, and at the European micro air vehicle competition. Went really well, scored first. And then we decided as a team to make the software available as open source. And that is what really started PX4. Not quite, it was PX1 in terms of the software stack, but Mavlink and Ground Control. And then more and more projects picked that up. Also other Autopilot communities picked some of these things up, like Mavlink and Ground Control. And with the 4th rewrite of the PixArc software, PX4, 2011, we finally had the stable flight control stack version we wanted. And when I say stable, what I mean with not in terms of flight control stable, what I mean with that is in an architecture that was so future looking that it didn't require another major iteration. That's why it's called PX4. And it still holds today. With the publish subscribe infrastructure that we have, we had chosen a really modern middleware architecture that is aging really well. And then over the next couple of years, we started to add more vision-based navigation. We started to have the first Pixar kits, which made this all accessible to all of you. And then more and more products in the market, which led to the official creation of the Dronecode Foundation, which is now taking care of the open source project. So we've, in the last couple of years, really focused on growing the ecosystem, on making more of this available. So we have, with Mav SDK now, a way to interface it. We have full integration in ROS2, and we're deepening that further. And we've started to create industry standards. And I will talk more about that, but that's something that is seeing a lot of traction, is really important. And we are now starting to see that products are switching to these industry standards, and that's a really important moment for our industry. And I think it's also good to review why is this important and why is open source the driving factor in the commercial industry, if you think about general computing, but also in the drone industry. And the explanation is simple. When you start a project like 2008, it's all small, and like, you can also do it in a company, you can do it proprietary. The problem is you start to have more and more functionality. You need the but you need the flight control hardware. So if you use open hardware, you get ever improving hardware. You need the flight control software. You need the communication protocol. You need a ground station. You need a middleware to your computer. You need an SDK. You need computer vision. You need obstacle avoidance, and more and more and more year over year. And so as all these things are growing linearly, so it doesn't feel like it's a daunting task, it's getting bigger and bigger. And so you inevitably end up with this exponential amount of software, exponential amount of cost that any particular vendor has to handle by themselves, which at some point, even is for a pretty large company, not feasible. And so the end result is that you start to adopt open source software. And that's exactly what we're providing as a community. So if you want or need to explain to somebody why open source is the way to go, why it is important, and why it is in the long run the only way to develop software, unless you are a massive company in your space with a massive market share, this is a pretty good way to reason about it. So now let's assume that you're working for a company, or you're taking a company perspective. What you're always worried about is, yeah, but what about my product? How can I sustain in a market if everybody's using the same? And the answer is, well, nobody said that you have to completely open source your whole product. It's just a very good way for the infrastructure. So you can still build proprietary capabilities and differentiation on top, and functions that make your product different. This can be in software, this can be even in PX4 modules. We support to build PX4 modules out of tree. And very often, though, it is around your workflow, the user interface, the interaction, even the whole product, including the physical hardware. So generally, I would worry more about the customer as a company than about being differentiated on the technology, because what matters to the customer is whether you are customer-centric or not. So you have that differentiation, and you have that at a given point in time. Now, if you adopt open source software correctly by layering your work on top, you can bring that differentiation along in time to a future model, and you don't have to redo the infrastructure work. So your product grows as the open source software is growing in capability and features. If you feel that is challenging to you, you don't know exactly how to do that best, or you tried that and you were not successful, please feel free to approach me on the PX4 Slack channel or via email. This is a very common conversation and is something that can be mastered and can be done successfully. Now, typically when we have these conversations, I have a graph like that, which is on a very high level, understandable, but then people go like, yeah, but I don't know what it means, and it sounds like a good idea, but I'm not sure. Well, I'm quite thankful that the European Union has done a study on the impact of open source technologies. Now, this is not specific to drones, but there's no reason to not assume that it applies 100% to drones. And what you see there is that there was around 1 billion euros, so a little over $1 billion, investment into open source software in the European Union, about the same size in terms of number of developers as the US, which resulted in an impact on the European economy of 65 and 95 billion. So that's a 60 to 90 or 60 to 100x in value creation. That's massive. That's really massive. And if you look further, then the cost-benefit ratio tells us that if there were more open source contributions, like 10% more contributions, that would generate an additional 0.4 to 0.6 GDP. So that's a gross domestic product of the whole economy, not software, not specific to anything, and more than 600 additional startups. Now, if you think about that, like 10% more open source contributions lead to a growth of the gross domestic product that is about as big as the annual growth through the overall economic activity. Like, even if this is wrong by a factor of 10, it's still massive. It's massive. So let that sink in, because that really says open source, if the study is correct, and we have all reason to assume it is, it's a scientific study, that the value or impact of open source software is as important as any other activity that leads to annual growth. So I hope that really tells a completely different picture than our inside view of our development day to day. So maybe a good reason, again, if you have in the future a conversation around open source, refer to that study. You can Google it, Impact of Open Source Technologies in the EU, should get you that link, it's public. Now, another insight, and that's something that correlates very much with my personal experience, is that procuring open source software instead of proprietary software in the government, so public sector equals to government agencies, could reduce the total cost of ownership. I'm actually not a big fan of that statement personally, because open source software is not free, and nor should it be free, because we as contributors, we need to get paid still. We need to eat. So I'm not sure if it really reduces the total cost of ownership, but it can avoid vendor lock-in, and it can increase the digital autonomy. It can make sure that government agencies in the future can make more informed choices about the software they run and the way they run their software, because they have more ownership and choice. That open source is cheaper than proprietary software, I'm not a big fan of that argument. Now, what is really interesting, and I did not expect this, is that in the European Union, it's mostly small and very small businesses, so consultants, 1 to 3 people, companies that have a very specific niche product, who are most likely to contribute to open source software. Whereas if you look at the contributions and commits that come from the US, they're mostly made by large ICT companies. I've read that about a week ago. I'm still trying to wrap my head around that. Why is that so different? To add a little bit of color, I can understand both reasons. From a small company perspective, you might be adopting some open source project, like PX4, for example. You build a handful of drones per year, 10, 20, that serve a very specific purpose, maybe crop spraying or something like that. Not a huge market, but each drone adds a lot of value. And by being able to change PX4 a little bit for your use case, you can make it work for that use case. You can fulfill that niche, and it makes sense for you to contribute, because you might be contributing fundamental interfaces and functionality that have nothing to do with your crop spraying drone or mechanism, but they allow you to deploy upgrades to PX4 more efficiently. So it makes sense to me. I can also see the angle of large ICT companies. We don't have that yet in the drone space, as in really large. But if you contribute to the development, and that applies to Auterion as well, then you strengthen that ecosystem. Your product is embedded in that ecosystem. And so it's important to you that that ecosystem grows and is healthy because you're offering your overall service around that. Red Hat as a company is a really great example of that. Why that is so different in the US and in the EU, I don't actually understand that myself. I could see both patterns emerge on both sides of the Atlantic. But if you have further insights into that, why that is, I would really love to get your insights and questions. I'm still trying to grapple with that myself. I find it very interesting though. So what we definitely can say is that the drone industry is investing in open source. These are just a few of the corporate contributors to our space. And again, the same way as I'm deeply grateful for all the people that have invested their personal time into PX4, that of course is the same for companies, in particular the major sponsors of Dronecode, Auterion, Microsoft, and NXP. Those contributions are really important as well. Now, let's quickly look at this year. Oh, actually, the images are not loading, but that's fine. We still have quite a bit of usage in the consumer space in the drone industry. Not going to brush over the vast majority of consumer drones coming from DJI, and the DJI Mavic being virtually synonymous with a consumer drone today. But there are some products out in the market, for example, from Unique, that are based on PX4 and still out there. So that's cool. So I'm always hoping for more diversity to emerge. But I also do think as developers, we have to acknowledge that the products that DJI is building or that Skydio is building for consumers are awesome. And it makes sense for this large volume. Now, it's quite a different story for commercial and industrial. Being open, being more flexible, being able to integrate different payloads is absolutely key. You're not selling one system to millions of customers. You're selling it to hundreds or thousands max to customers. But then everybody needs something a little bit different. And so that is also the story why open source software has been dominating in the enterprise space. And the same is true for industrial with cargo drones. Now, let's look at where most contributions go. And if you look at it, to me, that makes a lot of sense. So PX4 is a little bit like the Linux kernel. It's the core interface. We actually mostly solved all the core issues, I would say, in terms of flight control. Right now, the most things we're solving is to make the system more flexible, more scalable, easier to interface, and to add robustness and productization features like control allocation and other things. So it makes sense that most contributions go to PX4. Then we have a lot of contributions going to Mav SDK, which is the easy way to use PX4, makes a lot of sense. Mavlink needs to be maintained. We're also partnering with other open source projects and industry players there very successfully. That's really important to have that as a neutral standard that is owned by many different stakeholders, and Q-ground control. Now, not going to talk about individual people here, but these are the top 10 contributors. Thank you so much for everything you're doing for the community. That's much, much appreciated. And the same way as for any open source project, you have the people at the core that move the project forward. And I'm personally deeply grateful for having marched along this path with you for so many years, and this is absolutely essential. Now, in terms of the contributing organizations, these are the organizations that contributed most. And now, what's coming up this year? We have this year, in terms of our standardization effort, a new standard, FMU v6U, contributed by Gumsticks, but it's not specific to their product. And that's a new flight management unit standard that they are shipping as part of their Raspberry Pi and flight controller combination. So really cool to see the standards picking up contributions. And now I want to talk a little bit about use cases of PX4, because that's also very often a question. So consumer, this is a unique Mantis G, definitely has been a use case. This is a Volansi cargo drone, also use case. Wingcopter cargo drone, lots of cargo drones. This is a system from Vantage Robotics for public safety. This is a medical cargo drone, or medical air assistance from Avi. Again, I think lately we're seeing more and more cargo drones. And we wanted to quickly show that in operation. So this drone flew BVLOS in Africa, in Botswana, with medical cargo, with PX4, on LTE. And that's really cool to see. And this system is using our latest and greatest in terms of system architecture. So it's using an onboard computer, in this case in the form of Skynote. It's using FMU V5X and all the latest and greatest. So really, really cool to see now these applications being brought really to important worldwide use cases. What we also see, and this is an application with a much higher volume, is the adoption of PX4 for large-scale commercial deployments. This is a Freefly Astro drone with PX4, again with the same modern architecture, another Skynote user, and this is the Astro. And the Astro is built as a workhorse for industrial applications. I'm expecting that to be a very popular thing. I expect that with the Sony 60 megapixel camera to really change how industrial drones are done today. And so really exciting to have this system on PX4. Sorry about that. And that gives you a little bit of an idea of how industrial adoption looks like in terms of the UX, in terms of how polished this looks now. And so I'm pretty proud that we as a community over the last years have been able to build systems and to build the infrastructure for systems that can be real workhorses and are really competitive despite the quite powerful proprietary alternatives and companies in this space. And that shows you how far you can take things with open source software. So really cool. So just continuing. This is another application, search and rescue with VTOL. That's a quantum systems vector. Also in this particular model running PX4. So really cool. Again, you see the spread, you see the different applications that can be driven with that. Or the Alta X, super heavy workhorse. So very high diversity. This is a pretty large drone you see here from Elroy Air. Or an over-actuated drone from Volero. So lots and lots and lots of use cases and applications. This is another one. in this case, a model by Watts Innovation, the Prism Sky. So it's you can see how these overall workhorse industrial systems are what seems to be our natural product market fit for what we're doing in this development community, be it for cargo or be it for inspection or be it for other applications that require proper industrial solutions. Good. So yeah, Vertical Technologies Delta Quad, another VTOL, or the Wingtra mapping system, which created this model, which I think is pretty cool. So you can also see that PX4 powered drones get permission to fly in very urban environments. This is a model that Wingtra captured in one of their recent flights. I think it's really impressive to have this scale. This is Zurich. And to have the whole city mapped out. Yeah, congratulations to them. I think this is a scale and a level of a model that shows what VTOL systems can do overall in this industry, and also how much regulators trust what we're building together as a development community here and what great companies can then bring to market. So really, really awesome. I hope this is pretty inspiring to all of us, in particular, given that regulations have been a problem in this industry for some time. I quickly want to talk about standards, and the order is actually the same order as in my keynote a year ago. And a year ago, I have been arguing that one of the key things that is missing for this industry is our ability to have the equivalent of the IBM PC. And all these minor differences in hardware are causing significant board maintenance overhead that is adding zero value to the end product. And even worse, sometimes what makes sense for the Autopilot manufacturer as a product innovation actually makes not so much sense from a software perspective. And the best example for that, for me personally, is Ethernet. Ethernet wasn't available for a very long time as an Autopilot bus, and that's actually bad because as we're starting to have higher and higher levels of autonomy, as we run more state estimators, as we run more communications on board, as the mission computer becomes a standard element of the drone system, just having UART isn't great. And so for the longest time, nothing with Ethernet was available. We've changed that over a year ago with the introduction of the FMEV5X and FMEV6X industry standards. And now we've worked as a development community with various hardware vendors. One includes Auterion, full disclosure. But what we're introducing now, and I'm just teasing this a little bit, is a low-cost community autopilot, not from Auterion, has nothing to do with it, with the ability to run Ethernet. You can see that in the Ethernet control links, link control LEDs here. And this is going to change our industry fundamentally, because there's no reason why you shouldn't run a packetized communication on board. It will unblock a million things that we're currently working around in a horrendous fashion. It will allow you to get significantly more data off the Autopilot to wherever it needs to go. And it will enable you to come up with I would say, more natural design patterns around the integration of ROS2 and PX4 and around many other things. So I'm really excited that 1 year with Silicon Crisis and everything, after we've introduced these standards, we now have products in the market that you can buy that have all this inbuilt. And while the right product is really just the microcontroller Autopilot, you still need the computer and everything. On the left side with Skynote, you actually have the computer inbuilt. So you have the whole package. I'm not going to make advertisements for either product, but these are implementers of the standard, and I'm expecting many more to follow based on the conversations we had. And I think this is going to change the industry forever. The other thing that might have sounded aspirational, but you will quickly see how it is a complete reality today, and again is going to change the industry completely, is the Pixhawk Payload Bus, PPB, which is intended for cameras, gimbals, cargo payloads, so it's not limited to cameras. And it includes, right now, we will extend that, the mechanical design for medium-sized camera payloads. And it is a complete mechanical, electrical, and software interface that allows you to build a complete solution. Now, it might have sounded aspirational a year ago, but here you go, a complete payload lineup, in this case from Freefly Systems, with their implementation and with the development kit for the Freefly Astro. Again, this is an industry standard. Freefly has been, the developer of it has been very supportive of the development community with it, but it is something that is completely neutral, can be adopted by anybody on the drone side, on the payload side. And I quickly wanted to show their sneak peek video for the Freefly Astro. So this is how it slides in and locks. And so what you have here, sorry, this, I can try to enable the audio, then you can hear Jeff yourself, maybe. I'll just skip through it. Okay, so what you have here is the insert, which is on the payload side. So that is what you would build into your payload. Then there's a piece of electronics with the connector. So the white part is optional. You can choose whatever you want. The black connector is what is part of the standard and what connects on the backside to the other standard piece. And then this top part is what goes into the drone with the latching mechanism. Now, what Freefly is going to provide is a development kit with this cable that allows you to develop your own payload for the Freefly Astro or for any other drone that is implementing this standard. And with the availability of the Freefly payloads, with the availability of Astro, and knowing that this will become a standard, you can really invest into this. And you can, as either as a drone manufacturer or as a gimbal manufacturer, safely assume that that's going to be around for the next decade or 2 or 3. And finally, we will get into a position where we will stop all burning effort and time on integrating payloads again and again and again, one-off into systems, and you can really focus on creating value to your end customer. I strongly believe that steps like this have impaired so far our industry, and that way too often we have been considering this sort of hard infrastructure work as proprietary because it has been hard, not because it has been adding value. And that collectively has held back our open industry versus proprietary players. Because we have just burned through effort that has added zero customer value. So I'm really grateful for what Freefly has done here, for what they are providing with Astro as a workhorse, and how fair and market oriented they are in contributing to this payload standard development. This, of course, will help to sell Astro, but it also will help to move our drone industry jointly into a completely new level. And yeah, I think you cannot underestimate how pivotal this very moment is. So I'm not going to use the full hour. I think keynotes that go on and on and on are not great. So I'm just going to recap the main things that we have been working on this year. And then I'm happy to take a few questions and maybe give you a little bit of your time back. So the 2021 priorities have been control allocation. What that means is that we're now in a position to react to motor failure. We actually had been working on this for the past 18 months, starting with very important contributions by Julien Lecoeur. But as it is usual, everybody gets busy, is looking into their short-term needs, and it took some time to pick this back up. So we've done that at a turn recently, and are now trying to drive that towards completion. And so there is a pretty good state now in master, and we're going to continue to work that. The ROS2 interface has made significant strides. We've tried to fit that into UART because we know there are a lot of autopilots out there with UART. My personal conclusion is this is futile. Let's move to Ethernet. So I'm super excited that we now have many choices with Ethernet in this industry available. And so this whole ROS2 PX4 harmonization, and we're going to continue to grow that together, is going to be focused around that, where we have fast links and can move fast forward. Beat has really helped to move the tuning UI and UX forward in QGC with PX4. We're not finished yet, but we've really made some strides. Daniel has done a million things, but I think the really key thing is the online IMU signal FFT filters. Probably we need more tuning and more testing on those, but once we're done with that, it will help to deal with the notch filtering and everything with a whole set of like weird configurations that people have issues with. And I think you can expect from an Autopilot this year, or at least next year, that it can deal with systems that I personally probably would have called unflyable a year or 2 or 3 ago and just asked people to fix it mechanically. But I think we're going towards a state of the industry where the really great systems are engineered correctly mechanically, but there's still enough out there that are not, and people start to expect the Autopilot to deal with pretty much anything that you throw at it. And we can't just avoid that. We have to be competitive on that front too. Working towards device trees for robots. Ben is working on that. I don't think it's fully finished, but we've had some navigator improvements. Julian, Roman, and Matthias are still working on that. We've added automatic tuning for multicopter and fixed wing, also for VTOL in combination. We've significantly improved the Keynote support, and we've streamlined board configuration. That is not fully default everywhere yet, but Peter has made significant strides there. Those are the priorities. Those are not the only things we worked on. Depending on your perspective, there might be completely different things that you're excited about. And that's a beauty of our development community. Yeah, and with that, let me stop share so you can see me a little bit better. I'm really excited of all the new things that are coming. I'm also really humbled that we now have 200 people that are here. The first time we have a more formal format, not just a YouTube link. more interactions and sessions that I'm hoping that will happen over the next couple of days. And then we're going to work really hard to make this a in-person interactive event next year, somewhere around the globe, maybe Zurich, maybe somewhere else. Maybe we'll have a multiple locations to make travel easier. Good. So for me, that is the end of my keynote and presentation. If you have questions, I'm currently looking into the questions tab. Okay, so I'm going to work through them. So first question was, what's the best way to get started with PX4? Vince has shared a link. I think that's a good way. Yeah, start with the developer documentation. Come on the PX4 Slack channel. I think we have a getting started /help channel. I'm just checking that myself to give you the exact. Yeah, there's a getting -started channel. Just post anything in there. We're going to try to help. And that's a good way. Insight into how regulation might impact PX4. We have always had contributions that tackle regulations. And so I would put that into two categories. And by the way, if you have more questions, just add to it. So one type of regulation impact is that somebody contributes parachute triggering support or geofencing support or some other feature that is important for a particular scenario because you need to show that you have this particular capability or fail-safe mechanism. So that's one way. The other way, and I think that's still a little bit out, is there might be eventually regulations on some of the software and testing development processes that you have to apply. I'm not necessarily saying DIA 178 or anything like that full force, but into that direction. And we're watching that very, very closely. The good thing is we have significant enterprise traction with PX4. We have companies that have a size and a commercial interest to sustain the development to make that happen. So I wouldn't be worried if eventually DIA 178 Lite or something like that is going to be required, because I'm confident that we will get that as contributions by various larger companies using PX4. And we're starting, if you look at our internal development, we're starting to make strides towards that. We have more and more testing. We have more and more unit testing. We have more and more fuzz testing. We're not tracking requirements on an individual basis, but I'm sure that would be also doable if we had to. And what we also do more and more is to identify what is the safety critical core of the system. And for example, is mission management part of that, or do we need to simplify that? And we're going to make sure that we're able to federate PX4 more so that you're able to have a really critical core and then not so critical other parts. Good. Then in terms of the payload standard, so that was another question. So the payload standard, yeah, I showed a works well camera. There are two classes of payloads with the Pixar payload bus. One class of payload is implementing the complete Mavlink payload spec. That basically means like a Gremsy gimbal or a Freefly gimbal, you connect to it and it just talks the absolute default. The other approach you have as a vendor is to talk to the end payload straight via USB. And so the Workswell camera support you saw is The whole lineup is supported, but in the particular case of Astro. So you have both options. The next question is on Ferns. How do I get a hold of a PPB? So you can, in theory, build it off the documentation in the payload standard. Please ping us. If not, sometimes, there's a small detail missing. But based on what we know from Freefly, they will be offering this development kit shortly. So you might want to check out their website in the next days for updates. Then the next question from Max, does the micro RTPS bridge work with Ethernet already? Yes, it does. We've layered that correctly. We have been just focused on UART so far because we wanted to bring as many legacy systems along as possible, but I think at this point it makes more sense to focus our energy on the future now that there is so much hardware available that you can choose from. So that's going to be the focus. Then next question from SF4, and I'm actually really happy that that question comes. How future capabilities like control allocation in the open source stack or Auterion stack, there is no Auterion stack. Auterion as a company is basically offering a software distribution of PX4, but everything that Auterion does goes back upstream. So anything that has been mentioned today or that Auterion will talk about in the future is available in upstream, and that also explains why Auterion is the largest contributor. Brent asked, handling motor failure. Yeah, it means handling any type of failure. So as long as you can detect it, you know what the state of the motor is, so you have some telemetry like D-shot, then it can dynamically reallocate actuators. Then next question, do you ever see the possibility of the FCU including a ROS-capable computer on board? I'm not sure what the question is because that's what we're pretty much doing already. So most people building research or commercial systems are already having some type of onboard computer. A lot of them run ROS. If you don't want to build that yourself, you can have a solution from Modal AI or Gumsticks or Auterion. So many different options along those lines. Then next question, PX4 perspective integrating different types of drone systems, including balloons. So I'm laughing because in general, we have already airship support. So it should work. Now, airships are not the thing that a lot of people are typically working on. So you might have to do a little bit of system integration to work through individual things to get the right behavior. But from a system architecture perspective, you already have federated modules that you can choose from, and you might just need to write your one airship attitude controller. You can probably use the position controller from the multicopter. So it shouldn't be hard. I think the difficult or the important part is to get up to speed on the PX4 architecture and to understand how you can fit in your thing. You might want to look at the differences between the rover attitude and position controller and the fixed wing and the multicopter, and that should give you an idea of how these things are different and how a lot of the rest of the code base is shared and common. Okay. I think, okay, one more question. So we have 7 more minutes. in what areas do I see computer vision aiding PX4 outside of navigation or obstacle avoidance? Precision landing, for sure. I know quite a few companies that have developed some type of docking mechanism or some type of landing pad mechanism based on computer vision. So that's a typical application. Then question from Roman, does the new mixer allocation deal with VTOL configuration? Yes, it does. It does. We've tested that quite a bit. We're currently testing mostly on multicopter because that has been the important need. But yes, the whole point of the control allocation effort is to make the VTOL controls more scalable so that you don't have this switching regime, which we have and which is industry standard right now, but it's in particular for tilt rotors and other vehicles that basically have also physically the capability to have this more continuous motion, to have that in there. So from a technology perspective, it's there. You can fly it, but it might need polishing, testing, contributions. Right now, we've polished it for multicopter first, but this would be the classic where, join the effort, build the system, choose something that's nimble and easy to maintain, like a convergence VTOL, and contribute to the development. It's certainly close or already done and just needs polishing. Then integration support of UV can and lack of industry adoption. That is a good question, and I would love to have that conversation offline in more detail to understand more about it. From my perspective, I've seen over the past 12 months a whole flurry of UV can boards. You can buy pretty much anything today, GPS, airspeed, anything, and it'll just work. It's using the standard UV can messages. So that's pretty cool. And we have added, just to point that out as well, we have added a complete infrastructure for PX4 node development. So if you want to build a GPS that runs PX4 on the GPS and is interfaced via UAV CAN to the main flight controller, look at the upstream repo. It's in there. It's called GPS CAN node, I think. We've also introduced a flow CAN node. That's something that Arc Electronics has been working on and contributed. So there are lots of examples of CAN nodes that run PX4, but you can also buy all sorts of peripherals by now online. So maybe you can write me on Slack what other needs you're seeing that I'm missing, or maybe I can point you to these devices that might not have been obvious. And maybe that's just a hint at our documentation that needs to list out more of these options. Okay. This is the last question I'm going to take, and it's a really good one. Rajiv is asking if there is a way to change the frame type of the drone in midair to support morphing. I wouldn't do it as frame type. I think that's too brutal and will not work. But what you want is control allocation. Because if you change the control allocation matrix, that's all you need. And then you can deal with morphing, like changing baseline of propellers or changing the attitude of propellers. And it's going to make your job really simple because you just need to give it the right allocation matrix. And the rest will be figured out by the control system. So look at control alloc, ask on Slack for pointers, but with that, it's darn simple. Cool. Thank you for all of your questions. We're at time. Yeah, I enjoy the next 2 days. Again, thank you for contributing to PX4. Thank you for using it. Thank you for attending this summit. And last ask from us, from an organizer perspective, please give feedback. either one-on-one. We'll send around a survey in sessions. Really, really important for us to hone this format, and hopefully we can have that next year in person. Of course, with live stream support, so people can join remotely. Thank you all. Bye.